In this video, we're going to solve the system of equations negative 2x plus 9y equals 13 and negative 9x plus 5y equals 23 using the elimination method. And the idea of the elimination method is we want to get the coefficients on the same variable, so either the x or the y in this case, to be opposites of each other. So for instance, if we had a positive 10 on one in one of the equations and a negative 10 on the other in the other equation, that would be a good thing, or a positive 17 and a negative 17. And the idea is we can add the two equations together at that point, and then that variable is going to be eliminated. So looking over this problem right here, typically you want to look to see if you can just multiply one of the equations by a number to cause you to have the opposing coefficients on one of the variables. But in this case, we can't do that because there's nothing we can multiply by 2 to give us a 9, and not at least a whole number. And there's nothing we can multiply by 9 to give us a 5 or a 5 to give us a 9, again, without introducing fractions. And so the best thing to do in this case is we can multiply one by a number and the other by another number to cause us to have those opposing coefficients. So for the first one, what I'm going to do, just for ease, I'm just going to eliminate the x's. I'm going to multiply the whole first equation by 9, because the 9 times the negative 2 will give us negative 18, and I'm going to multiply the entire second equation by negative 2, because the negative 2 times the negative 9 on the x will give us a positive 18. So the positive 18 and the negative 18 will cancel each other out. So I'm going to go ahead and work on the first equation. I'm just going to do that in blue to keep it all together so you can keep it separate in your mind. So distributing the 9 to all of the terms in the first equation, 9 times negative 2x is going to give us negative 18x, plus the 9 times the 9y is going to give us 81y, and that's going to be equal to 9 times 13, which is going to be equal to 117. So there's our first equation, and we have the coefficient on the x that we want. So now the second equation, we're going to multiply everything by negative 2, and that means both sides of the equal sign. So negative 2 times negative 9x is going to give us positive 18x, and that's what we wanted. We now have a positive 18 and a negative 18, so that's good. Negative 2 times the 5y is going to give us negative 10y. And then the negative 2 times the 23 is going to give us negative 46. And so now that we have opposing coefficients on the x's, we're going to combine these two equations with addition. So negative 18 plus 18 is going to give us 0, so the x's are now gone. The 81y minus 10y is going to give us 71y. And the 117 minus 46 is going to give us 71. So this is nice. It looks like the numbers have smiled upon us this time, because solving for y, we can divide both sides by 71. That's going to cancel out there, divide by 71 here, and that's going to give us y is equal to 71 over 71, which is the same thing as y is equal to 1. So we're solving a system of equations, so we need to know the x and the y value, so we're not quite done. So now we can plug 1 in the place of y in any of the equations we've got. Now we have 4 different equations we can look at, the two original and the blue and the green one that we modified. But I would just go back to one of the original equations. Now whichever one you plug it into, you're going to get the right answer, as long as you don't make any algebraic mistakes. But I say go back to one of the original ones because it's a little bit easier, smaller numbers to deal with. And the one I'm going to go with was negative 2x plus 9y equals 13. And keeping in mind, we're putting 1 in the place of y, so we'll have negative 2x plus 9 times our value of y, we just found out was 1, is going to be equal to 13. And now solving for x, we'll have negative 2x. Subtracting 9 from both sides is going to give us 4. Divide both sides by negative 2, we get x is equal to negative 2. And so there's our x and our y value. So if you visualize these two equations being lines, they would intersect at the point negative 2, that's the x value, 1, that's our y value. Now you can always go back and check yourself on these problems. It's easy and nice to do. You have an x and y value, so just plug the x value in the place of x and the y value in the place of y in both of the equations and make sure everything works out. So in the first equation, you should get 13 on the left-hand side. On the second equation, you should get 23 on the left-hand side, and you'll get something like 13 equals 13 and 23 equals 23. And that's a good way of checking yourself if you have some extra time in these problems.